Your database backups shouldn't leave users staring at a blank screen wondering if anything's happening. You'll see how to implement absolute progress reporting in FastMCP, where we'll track each table backup individually and send precise progress updates. No guesswork, just clear status communication from start to finish.
At MCP, Tool. Async Def Backup Database, CTX, Context, SDR. Backup database tables with absolute progress. Tables equals users, orders, products, inventory, logs. For I, table and enumerate tables. Await CTX, info F backing up table, table. Hash report absolute progress. Await CTX, report progress. Progress equals I plus 1, total equals len tables. Hash simulate backup time. Await Asyncio, sleep 05. Return, database backup completed.
This demonstrates absolute progress reporting in long-running operations, a pattern that provides deterministic progress tracking by using concrete completion metrics rather than percentages. The technique maps discrete work units to progress values, creating a direct correlation between completed tasks and progress updates. What distinguishes this approach is its precision. Each progress increment corresponds to a tangible unit of work, making it ideal for operations with known, fixed steps. The pattern operates by decoupling progress reporting from the core logic through a context object that handles asynchronous updates. Progress is communicated as a ratio of completed units to total units, allowing clients to render accurate progress indicators without needing to understand the operation's internal structure. This separation of concerns keeps the business logic clean while enabling rich user feedback. Absolute progress reporting solves the ambiguity problem in long-running tasks, where users need concrete evidence that work is progressing. It's particularly valuable for batch operations, database tasks, or any workflow with distinct phases, as it prevents perceived hangs and provides actionable feedback. The trade-off is that it requires known work units up front, making it less suitable for open-ended operations where the total scope can't be predetermined. Let's break it down.
At MCP, Tool. Async Def Backup Database, CTX, Context, SDR. Backup database tables with absolute progress. Tables equals users, orders, products, inventory, logs.
The @MCP tool decorator exposes this async function as an AI callable tool in FastMCP. All tools must accept a context parameter for logging and progress reporting, which we'll use to track backup status. The tables list defines the exact database tables to backup, ensuring predictable, ordered processing. This hard-coded approach works for fixed schemas, but would need extension for dynamic table discovery.
For I, table and enumerate tables. Await CTX, info F backing up table, table.
This iterates through each database table using enumerate, which provides both the index and table name. The CTX, info, call logs progress to the user interface, maintaining transparency during the backup operation. All FastMCP tools should use this context parameter for consistent logging and progress reporting.
Hash report absolute progress. Await CTX, report progress. Progress equals I plus 1, total equals len tables.
This reports absolute progress to the calling system, using the current iteration count and total items. The context object handles progress tracking, enabling real-time feedback during long-running operations.
Hash simulate backup time. Await Asyncio, sleep 05.
This simulates real-world backup latency. The 0.5-second delay mimics actual database I/O time, making the progress reporting realistic during testing. Without this, the backup would complete instantly, defeating the purpose of demonstrating progress tracking.
Return, database backup completed.
This returns the final status message to the AI caller. FastMCP tools must return strings for AI consumable responses, ensuring the system can relay completion status back to the user. Progress reporting pattern. FastMCP's context object transforms long-running operations into observable processes, using absolute progress values to bridge the gap between server execution and client perception. Progress updates require integer values for both current and total, never percentages or floats. This pattern eliminates the illusion of hanging by making time visible through structured updates.
The progress bar that never moves forward is the only one that tells the complete truth.